Hey everyone, welcome back. Quick question. Have you ever wanted to build something with AI that actually uses your data? Not some generic chatbot, not just copy pasting from a tutorial, a real app that you built, that you deployed, that you can show people. That's exactly what we are going to do today. So, in the next topics, you're going to build and deploy your first RAG application from scratch. No machine learning degree, no PhD, just Python and a laptop. Let's go. Okay, so here's the thing. ChatGPT is incredible, but it has a dirty secret. It was trained on the internet, books, Wikipedia, Stack Overflow, but not your company's internal docs, not your product manuals, not your personal knowledge base. So, what happens when you ask it something specific? It makes something up confidently, convincingly, completely wrong. That's called a hallucination, and it's a nightmare in production. Three problems right there on the slide: hallucination, no context, and stale data. RAG fixes all three. Let me show you how. RAG, Retrieval Augmented Generation. Sounds scary, but it's not. Stick with me. Here's the online version. RAG equal to your data plus AI power. Instead of the AI guessing from memory, it first retrieves the relevant parts of your document, then generates an answer grounded in what it actually found. Look at the two boxes. Without RAG, the AI says, I don't have information about your company policies. But with RAG, the AI says, based on your HR policy document, leave must be approved at least 2 weeks in advance. Same AI, different result because now it has context. That's the magic, and you're about to build it. So, here's exactly what we are building today: five things. One is upload any PDF or text document. Two, auto index it into a vector database. Three, ask questions in plain English. Four, get AI answer that come from your document. Five, deploy it live so you can share it with anyone. That's a real production level drag app, and you're going to have it running in 20 minutes. I'm not exaggerating. Let's break it down step by step. Before we write a single line of code, let me tell you a story. This is a real situation I have seen 100 times. I have 500 internal documents. Nobody reads them. I tried asking ChatGPT, it made stuff up. But sounds similar, right? This engineer had the data, they had the AI, but they didn't have the bridge between them. That bridge is RAG. And by the end of this video, you will know exactly how to build it. Alright, let's get into the actual mechanism. Three steps. That's all drag is. Just three steps. Step one is store. You take your documents, chop them into smaller chunks, convert each chunk into a vector, which is basically a list of numbers that represent the meaning of the chunk, and you save everything in the vector database. Step two is to retrieve. When a user asks a question, that question also gets converted to a vector. Then you search the database for the chunk that are most similar in meaning to the question. Instant, accurate. Step 3, generate. You take those retrieved chunks, the actual relevant context, and you send them to an LLM along with the question. The AI now has everything it needs to give a real grounded answer. So, thing is store, retrieve, generate. That's RAG. Okay, one concept you need to understand before we code is embeddings. Here's how I like to think about it. Imagine GPS coordinates, but instead of location, they represent meaning. The word dog becomes a list of numbers, maybe 0.23, 0.87, 0.12. The word puppy becomes almost the same numbers, 0.24, 0.86, 0.13. But spaceships, totally different: 0.91, 0.04, something. Why does this matter? Because when you ask what's the policy on pets in the office, the system finds chunk that are semantically close to your question, not just keyword matching understanding. That's the real superpower here. Now let's pick our tools. Here's our complete tech stack for today. It's all free to start. Python 3.10 or higher, our main language. Next, OpenAI API if you want faster and cheaper. This is our LLM for generating the actual answers. Next, ChromaDB, an open source vector database that runs entirely on your local machine. No cloud account needed. Next, LangChain. This is the glue that connects everything together. It handles the chunking, the retrieval, the chain logic. Next is the Streamlit. This gives us a beautiful web UI in literally 10 lines of Python. That's your stack. Let's install all. Open your terminal, one command: pip install langchain chromodb OpenAI Streamlit PyPDF. Run that, let it install. Then one more I have given the next line, pip install langchain openai langchain community. Now go to platform.openai.com, grab your API key and export it in your terminal like you see on this. If you want to use Grok instead, it's even cheaper, sometimes 10x faster. Just swap the API key and model name later. I'll put both in the GitHub repo linked in the description. Done. That was 2 minutes of setup. Now let's actually write some codes. First thing is we load our document. Two imports at the top, PyPDF loader to read PDF files, recursive character text splitter to chop them into chunks. Then three lines of actual logic I have mentioned. Loader, PyPDF loader, give it the path to your PDF. Docs reads the whole thing into a memory. Then we create a splitter with chunk size 500 and call split documents. That's it. Now, about the chunk size of 500, that's roughly 100 words per chunk. Too small and you lose context. Too large and retrieval get fussy. 500 is a great starting point. We'll talk about turning this later. This is where the real magic starts to happen. We import two things, OpenAI embeddings and Chroma, then three lines of the codings like embedding equal to OpenAI. This connects to the OpenAI API to convert our chunks into those numbers we talked about. Then Chroma dot from documents, we pass in our chunks, the embeddings model, and a directory where ChromaDB will save everything locally. So run this once, it indexes your entire document and saves it to disk. For a 100-page PDF, about 5 seconds, maybe less. And your data never leaves your machine. It doesn't go to any cloud. It's fully local. That's a huge deal for sensitive data. Now we assemble the chain. This is the core of RAG. Import chat open AI and retrieval QA. Line 1 LLM equal to open AI with GPT-4o mini. This is the cheapest GPT-4 class model. Perfect for this. Line 2 we create a retrieval from our vector database. The K3 means grab the three most relevant chunk for each query. Line 3 retrieval QA from chain type. We give it the LLM and the retriever. LangChain handles the rest. That's it. 7 lines total. You just build a production quality RAG pipeline. Let that sink in. Let's actually use this thing. Set your query any natural language questions. What is the refund policy? Then call QA chain.invoke, pass the query, get the result. And here's the answer it gives. Look at this. According to section 4.2 of your return policy document, customers are eligible for a full refund within 30 days of purchase, provided the item is unused and in original packaging. It cited this section. It was specific. It didn't make anything up. That's not ChatGPT hallucinating, that's your AI reading your document, answering your question every single time. Okay, let's now make this look for good for users. This is my favorite part. We are going to add a full web interface in 10 lines. Import Streamlit, then add the command mentioned in the screen, then run this in your terminal, Streamlit run app.py. Your browser opens automatically. You get a clean, professional looking app. Text input at the top, A answers below. Share this with your team tomorrow morning. They won't believe you built it in 20 minutes. Let's pause for a second and just appreciate this. You loaded and chunked a real PDF document. You generated semantic embeddings with OpenAI. You stored vectors in ChromaDB locally, privately. You built a retrieval QA chain in 7 lines of Python. You added a full web UI with Streamlit. That's a complete end-to-end RAG application. 6 months ago, building something like this would have taken a team of ML engineer weeks. You just did it under 12 minutes of this video. Now, let's make it even better and let's talk about the mistakes people make. Alright, real talk. Here's are the mistakes I see all the time. Mistake number one, chunk size too large. I have seen people set chunk size to 10,000. That's like feeding the AI an entire chapter of every question. What happens? The AI gets overwhelmed, it costs you 10x more in API tokens, and the answer gets vague because there's too much irrelevant context. On the other hand, too small like 100, you lose the context around the actual answer. The sweet spot 400 to 600 characters. Start at 500, test with your specific documents, adjust based on the answers you are getting. It takes 5 minutes to experiment, worth every second. Mistake number two, the K parameter. K is how many chunks get sent into the LLM with each query. K1, too narrow. You might miss the paragraph right above the one that actually has the answer. K10, You're burning tokens and might overflow the model's context window, gets expensive fast. K3 is the sweet spot for most use cases. 3 chunks gives enough context without overloading. Here's the rule of thumb. Start with K3. If your answer feels incomplete, bump to 5. If you're on a tight budget, try K2. Simple, practical. Now let's level up this app. Right now, our app is stateless. You ask a question, you get an answer, but it forgets the previous questions immediately. What if you want a real conversation? What's the refund policy? Okay, what about damaged items? And what if I don't have the receipt? That's where conversational buffer memory comes in. So import it, create a memory object with memory key, chat history, then swap retrieval QA for conversational retrieval chain, pass in the memory. Done. Now your app remembers the entire conversation. It's like ChatGPT, but trained on your own documents. Your users will love this actually. Once document is cool, but what about your entire knowledge base? 5 lines of Python. Import glob, create an empty list called all docs, loop through every PDF in your docs folder, load each one, extend the list, then chunk and embed all docs exactly like before. ChromaDB will handle the rest. Think about what this enables. A legal firm could index thousands of case files, a HR department could load their entire policy library, a SaaS company could embed their whole help center. One query interface, every document, instant retrieval. That's the kind of thing that gets you promoted. Okay, you have built this thing. Now let's put it on the internet. 3 options, all with 3 tiers. Option 1, Streamlit Cloud. This is the easiest. Push your code to GitHub, connect your repo on share.streamlit.io, click deploy, done. Option 2, Hugging Face Spaces. Great if you want visibility in the AI community. Huge audience for AI demos there. Option 3, Railway or Render. More control, better for production traffic. Both have solid free tiers to start. My recommendation for today, start with the Streamlit Cloud. You will be live in under 5 minutes. No DevOps, no server configuration, just ship it. You might be thinking, okay, this is cool for demos, but is this actually used in real world? Yes, everywhere. Let me give you 5 examples. In healthcare, if you see, nurses use RAG to query patient protocols instantly. No more digging through manuals during emergencies. Next, legal. Lawyers search case law across 10,000 documents in seconds instead of hours. Finance, analyst Q&A on earnings report and regulatory fillings. Education, students get tutored directly from their textbook content. E-commerce, shoppers gets instant answer from product manuals without calling support. This is not a toy, this is production A, and now you know how to build it. I get this question constantly. Should I use RAG or fine tune a model? Let me settle this with a comparison. Now, setup time, if you see, RAG takes minutes, fine tune takes days to week. Cost wise, if you see, RAG cost you a fraction of a cent per query. Fine tuning can run you anywhere from $1,000 to $100,000. Next, updating your data. With RAG, you just reindex instant. With fine tuning, you have to retrain the entire model. Next, data privacy. If you see, RAG can be fully local, but fine tuning usually means your data goes to a cloud provider. For 90% of real world use cases, RAG wins on every dimension, whereas fine tuning has its place, but start with RAG always. Let's talk money because this is where people get surprised. Indexing 100 pages with OpenAI embeddings just about 4 cents one time. Each query using GPT-4o mini about 1/10 of a cent. 1,000 queries a day leads $1. ChromaDB free. Runs locally, no subscription. Streamlit cloud hosting absolutely free. You can run a real RAG app serving real users for under $2 a month in API cost. That's less than your morning coffee. There's no excuse not to build this. Now let's look at the complete picture. Your PDFs and the text documents go in on the left. They get chunked by the text splitter. Each chunk goes to the embedding model, that is OpenAI in our case. The resulting vectors get stored in ChromoDB. That's your offline indexing pipeline, one-time setup. Now at query time, the user types a question. The retriever fetches the most relevant chunks from ChromoDB. Those chunks plus the questions get sent to the LLM. The LLM generates a grounded, context aware answers. 2 pipelines, one for indexing, one for querying. That's the full RAG architecture. Simple, clean, powerful. This is the tip that separates good RAG from great RAG. custom prompt templates. By default, LangChain uses a generic prompt, but you can control exactly how the AI behaves. Look at this template on this slide. You are an expert assistant. Answer only from the context provided. If the answer is not in the context, say I don't know. That one instruction. If it's not there, say I don't know. Completely eliminates hallucination. Your AI won't make things up. It will be honest when it doesn't have the information. That's the difference between a demo and a trustworthy product. Always use a custom prompt in production. Always. Now let's talk about what happens when your app gets popular. At the MVP stage, ChromaDB plus Streamlit, perfect for internal tools, demos, proof of concepts. When you start getting real traffic, move to Pinecone or Vivid. These are managed vector database that scale automatically. Wrap your logic in fast API instead of Streamlit for better performance. Enterprise level, you can use PostgreSQL with the PG vector extension, proper authentication, usage analytics, rate limiting, the full production stack. The beautiful thing is your core RAG code barely changes. You're just swapping out components as you scale. Start simple, ship fast, scale when you need to. One more thing before we wrap up. You don't even need an API key to run RAG. Olama lets you run Llama 3, Mistral, Gemma all on your local machine. Free, private, fast. ChromaDB is already free and local. LangChain is fully open source. Streamlit is open source. Put it all together and you have a complete RAG system that costs $0 to run and keeps your data 100% on your machine. For healthcare, legal, finance, anywhere data privacy is critical, this open source stack is a game changer. Let's recap the exact timeline. First, we installed Python packages, load and chunk your PDF, create the vector store, build the retrieval QA chain, add the Streamlit UI, deploy to Streamlit Cloud. By this, you have a live URL, a real app on the internet built by you. The full source code is in the GitHub repo. Copy it, run it, modify it, make it yours. Let me leave you with this. 6 months ago, building a RAG app required a team. Today, you just did it alone in 20 minutes. No degree, no PhD, no machine learning background. Just a laptop, Python, and the willingness to try. Here's your challenge. Today, build your first RAG app. Use a document that matters to you, your notes, your company docs, your research papers. This week, deploy it, share the link, get feedback from real users. Next month, put it on your resume. If this helped you, hit like, subscribe for more, drop a comment and tell me what you're building, and share this with someone who needs it. I'll see you in the next one.